Hello, welcome once again. Today we want to find the value of x given that you have 2 minus x equals 2 raised to the power minus x. So guys, this problem is a little bit difficult, but let's see how to solve it by using Lambert's W function. We have it to be solution. So we have 2 minus x equals 2 raised to the power minus x. So now from here, guys, we can recall that when you have E, L, and A always equals A. This is true because we believe that this exponential E and natural log Ln will cancel out. Then we're going to get back our A. That means we can replace this one here. We have it to be 2 minus x equals E, then Ln 2 raised to the power minus x. Now guys, recall according to law of indices, when you have this, definitely this one will come here, then we have it to be 2 minus x equals E, then we have minus x Ln 2. So according to the law of logarithm, when you have log a raised to the power b, this equivalent to b log a. This is true. Now, from here, let us multiply through by L and x in order to do some manipulative here. Now, let's multiply through by E raised to x, L, and 2. Then when we multiply through by this, we are going to have something reasonable from here. We have 2 minus x, then multiply by this E, x, L, and 2 equals, when you multiply this together with this, we have E raised to minus x, L, and 2 dot E raised to power x, L, and 2. Now from here you can see they have the same base according to law of indices. When you have a number that is with different power but the same base, take one base, add their power together. Now from here we have this to be 2 minus x, then E raised to power x, L, and 2 equals, we take one here, that is their base, then we have this to be, minus x plus x, then L and 2. So from here, obviously we have 2x, 2 minus x multiplied by E raised to power x, L, and 2. From here we have this to be equals, this minus this minus x plus x will be equals 0. Then 0 multiplied by L and 2, we have it to be equals 0. Now from here guys, we have this to be 2 minus x, then multiplied by E raised to power x, L, and 2 equals, E raised to power 0 equals number, because we believe that any number raised to power 0 will give us 1. Now, from here, we have 2 minus x, then multiplied by E raised to power x, L, and 2 equals 1. So now guys, from here, we have x here plus x, then we have minus x here. To interchange this, we can say let's multiply through by minus. When we multiply through by minus, then we are going to have this to be x minus 2, then E raised to power x, L, and 2. Then this will change to minus 1. Now after that, let's also multiply through by L and 2. When we multiply through by ln2, then we are going to have it here from to be x minus 2, then ln2 e raised to power x ln2 equals minus ln2. So from here, we want to do some manipulative, guys. Just keep looking. Now from here, we have, when we have at the both side, when we divide both sides by e raised to 2 ln2, then we divide this one too as e raised to 2 ln2. We believe that this and this we cancel out and we have this one back. So having it here, it won't affect them, because obviously this will cancel this. Is that when you have a divided by b, that equals c divided by b. So this expression is obvious that this will cancel this, then you have your c to be equals, you have your a to be equals c. Because when you cross multiply, you have c multiplied by b, you have it to be cb. Then when you have this one multiplied by this, you have it to be ab. This will take away this, then you have your c to be equals a. So having it here like this doesn't affect them. Now let us see what will happen if that will be the case. Now from here we can have this to be x minus 2. Now we have ln2. So from here, guys, take a look at this. We have it to be e raised to power x ln2. Now when you want to apply the law of indices, they have the same base. So we can subtract their power by having this one to be minus 2 ln2. And we're going to have this to be equals this. You can have it to be minus ln2 divided by this will be e raised to power ln2 2 raised to power 2 by taking this one back here. So now, guys, we have this to be x minus 2, then ln2 e raised to power, we have x minus 2 here, we can factor it out to be x minus 2, then ln2 equals minus ln2 divided by e raised to power ln4. So now from here we have x minus 2 ln2, we have x minus 2 ln2. That means we have the base to be equals to the power. We have to recall from Lambert W function that says when you have w of a, then multiply by e raised to power a, this always equals a. So far the base and the power are the same, so we are going to get back our a. So by introducing, now from here we have to record that this will cancel this, then we can easily have this to be minus ln2 divided by 4. So by introducing w function to both sides, we have it to be w of x minus 2, then ln2 e raised to power x minus 2 ln2 equals w of minus ln2 divided by 4. So by applying this expression here they have the same base, the same power. So therefore this implies that we have this to be x minus 2, then ln2 equals w of minus ln2 divided by 4. So now from here, when we divide both sides by this, then this one will now be divided by ln2. When we divide both sides by ln2, this will cancel this, then we have this. So now from here we have x minus 2 to be equals w of minus ln2 divided by 4, then all divided by ln2. So which means that from here we have our x to be equals w of minus ln2 divided by 4 or divided by ln2 plus 2 by collecting the like terms. So this will change to plus. Now, when we take note of this like this, we can have it to be question 1. Now, let us recall from here. When we recall from 1 that we have w of minus ln2 divided by 4, just recall from this w function. Let's see what will happen from here. We can express this as w of minus 4 ln2 divided by 16. We believe that from here, 4 here, 1, 4 in 16 will be 4. Then we have our 4 back. Then we have this. Now, obviously, we can easily have this to be w of minus 4 ln2, then multiplied by 1 divided by 16. Is this the same thing with this? What we have here. Now, mind you that when you have e raised to power ln a, this equals a. So by applying it here, we can have this to be w of minus 4 ln2, then e raised to power ln 1 divided by 16. Then we have it to be like this. So if we have this to be w of minus 4 ln2 e raised to power l, and we can have this to be 2 raised to power minus 4. 2 raised to power minus 4 equals 1 divided by 16. 2 raised to power 4 equals 16. So when you introduce minus, it will be 1 divided by this. Now, from here we have w of minus 4 ln2, then e raised to power, this will come here, we have it to be minus 4 ln2. Here also, we have the same base with the same power. So this and this are the same. So therefore, we can have it to be minus 4 ln2, which implies that w of minus ln2 divided by 4 equals minus 4 ln2. Now, we have this to be equals this to be question 1. Sorry, question 2. Now, let us go and substitute the value of this here in equation 1 that we have here. So, we're going to have this to be x equals, the whole of everything here is what? Minus 4 ln2. From here, then we have this one to divide by ln2. Then we have it to be plus 2. Obviously, this will cancel this. Then we're going to have this to be minus 4 plus 2. Minus 4 plus 2 will be equals minus 2. So therefore, guys, the value of x equals minus 2. So if you are new here, once again, don't forget to share, like, comment, and subscribe to my YouTube channel for more mathematics tutorial videos. So now, we can check for the value of x. So now to check, we have 2 minus x equals 2 raised to power minus x. When x equals minus 2, what will happen from here will be 2 into minus 2 is it going to be equals 2 raised to power minus into bracket of minus 2. So from here, obviously, we have this to be minus times minus plus, then we have it to be 2 plus 2, which equals, this will be minus times minus will be plus 2, then we have it 2 raised to power 2. 2 plus 2, which is 4, equals 2 raised to power 2, which is also equals 4. So this is true. Bye-bye.